Good eye chaps, and welcome back to another video. Today we continue on the topic of mathematics, or to be precise, factoring. Factoring, a basic yet essential tool for mathematics and one of the most helpful in ambitions or goals that coincide with one of financial matters, like becoming a CEO or financial advisor. Alright, we pick off from the last lesson of factoring perfect square trinomials and go for a double lesson that happens to relate. Today we discuss factoring trinomials and quadratic trinomials. You can find it in the book on pages 30 and 38 respectively. In algebra, each operation follows simple rules and formulas. These new lessons likewise are not exempted. They both have specific formulas and I'll get to them in a minute. We begin with a quick recap of what factoring and trinomials mean. Factoring, in essence, is to break off a number into smaller numbers that when multiplied equal the original. For example, to factor 6 you would break it off into its own individual factors, like 1 times 6 or 2 times 3. Elementary mathematics. But in algebra, it's a bit more complicated than that. You have to deal with exponents, rational numbers, irrational numbers, and other more fancy terms. Some of those terms might be unfamiliar, but you'll catch the gist of it at the end of this video. Now, trinomial. Easy. If you recall, there are several types of polynomial. Those are monomial, binomial, and trinomial, which is 1, 2, and 3 terms respectively. In summary, if you see a random equation like 2x squared, that's a monomial. 3 plus 6 is a binomial. And 3xy minus 7x plus 7 is a trinomial. Easy to distinguish. Now, let's move on to the actual lesson. Let's begin with factoring quadratic trinomials. To distinguish a quadratic from other regular trinomials, you need to spot if it has the formula x squared plus bx plus c. Which sounds weird, but as I promised I'll explain. In the equation, each of the letters excluding the variable x can be substituted with numbers. So b can equal 3 and c can be 2. Or maybe b can equal 10 and c can equal 16. Let's stick with the first set. Let's say I'm hunting for some delicious math to devour. We spot an algebraic expression in the wild. The expression is x squared plus 3x plus 2. We're hungry for a quadratic trinomial, and we know it's a quadratic because it follows the formula x squared plus bx plus c. And with that, we have everything we need. Let's begin factoring. To start off, we begin by placing an empty binomial space, encased in parentheses, like this. The first term in this trinomial is x squared, which when factored is x times x. We place each of the x's in the first part of each space. Now it's not as empty as my soul. The second thing we do is get the second values with this simple process. To get the second values, we must find two numbers that when added equals b and when multiplied equals c. Confusing? I'll explain. Going back to the example, we simply must find two numbers that when added equals 3 but multiplied equals 2. Did you find it? Good job if you did. Oof job if you didn't. But yes, you're correct. It's 1 and 2. 1 plus 2 equals 3, giving us b. And 1 times 2 equals 2, giving us c. Now we have the second values, 1 and 2. So let's place each into the empty slots. Now, the binomials contain x and 1 as well as x and 2. We're missing something, actually. Because both numbers are positive, we'll add a plus sign before each number. So now we have x plus 1 and x plus 2. If in a hypothetical situation 2 was negative, then the binomial would look like this. X plus 1, x minus 2, since 2's negative. And now we're finished. To check if it's the right solution, we use the FOIL method, which I'm sure everyone forgot. To use FOIL, or first outer inner last, we take the first variable, aka x, multiply it with the other first variable, which is also x, giving us x squared. Then we multiply the outer variables, which is x and 2. Then we multiply the inner, or 1 and x. Then we multiply the last variables, which is 1 and 2. So we've got x squared plus 2x plus x plus 2. But wait, you shout, that doesn't look like the original. Well, listen here, you little twit, I was getting to that. Because 2x and 1x have like terms, we can safely add both together and boom! X squared plus 3x plus 2. It's the OG. Alright, since we covered this lesson quite easily, we'll be able to cover the other lesson easily as well. Mainly because they have very similar formulas. While the formula for factoring quadratic trinomials is x squared plus bx plus c, factoring trinomial has the formula of ax squared plus bx plus c. Not much difference, right?
No.
So let's substitute each of the variables except x with numbers. A will be 9, B will be 15, and C will be 4. So now we have the expression 9x squared plus 15x plus 4. So it's pretty straightforward, yeah?
No.
So we start off by multiplying the numbers of the first and last terms. So in our example, 9 multiplied by 4 would be 36. And similarly, we find two numbers that when added equal B and when multiplied equal C. Familiar, yes? Alright, so 1 times 36 is out. 1 plus 36 ain't 15. 2 times 18 is 36, but 2 plus 18 is 20. What about 3 times 12? Well, it equals 36. It also equals 15. Anyways, we got the two numbers of 3 and 12. Nice. So we continue by copying the same equation, but substituting the middle term or b with our two new values. So we got 9x squared plus 3 plus 12 plus 4. Another thing I should mention is that you'll want to bring down the variable from the middle term. So now, it should be 9x squared plus 3x plus 12x plus 4. You might be wondering why 3x came first and 12x, and why it's paired up with 9x squared while 12x is paired up with 4. Is there some sort of specific order? Nah. Just make sure that the first two terms of this polynomial have a greatest common factor and the last two terms have the same. We'll be needing it for the next steps. Anyways, now we have the equation. What do we do with it? It ain't gonna solve itself. So step 3, as you guessed, we find the GCF of the first two and last two terms. For the first two, we have the GCF 3x, while for the last two, we have the GCF 4. We get another set of parentheses, now ones that might look familiar. If you recall, this parenthesis structure is what you use in regular factoring, like finding the common monomial. Refer to page 2 of the book. Anyways, we place each of the GCFs outside the parentheses. Let's start to factor normally. 9x squared divided by 3x equals 3x. 3x divided by 3x equals 1. Remember that if multiplying exponents add them, then dividing subtracts. so we place the results in the parentheses, plus sign since it's positive. For the other one, divide 12x by 4 and we get 3x. Likewise, 4 divided by 4 equals 1. Let's put him inside. Alright, we're finished. The most simplified it can go is 3x times 3x plus 1 plus 4 times 3x plus 1. Fun fact, the most sure way to check if you're correct is by checking if the expression in both parentheses are the same, in which they are. 3x plus 1 is the same as 3x plus 1. But for the sake of it, let's check. The checking method isn't FOIL this time, but just the law of distribution, elementary math. I'll just speed run through it. 3 times 3 equals 9x squared carried down, 3x times 1 equals 3x carried down, 4 times 3x equals 12x carried down, 4 times 1 equals 4 carried down. Combine like terms, checking if it's OG equation, successful solving, ending equation. Alright, and that's the gist of it all. After learning, algebra just doesn't seem that scary anymore, right? Wrong. Algebra is scary. But hey, at least it's a bit simpler. As with every tutorial, I'll be leaving a very overpowered equation related to the subject here. Today we had 2 lessons, and naturally we'll have 2 equations as well. So if you want my approval and want to exercise your big brains, solve these. The equations are: factor 2x squared minus 4x minus 16 and factor 20x squared minus 17x minus 63. Good luck, chaps. As always, see you in the next one.